Hi there, my name is Miss Townsend and I love math. Welcome to Math with Townsend. This video is for grade 12 students who are in advanced functions and studying the trigonometry part of that course. This is one of two videos looking at trig fundamentals, and of course, because we're in grade 12, all of these questions involve angles measured in radians. So it's video number 2, hopefully you watched video number 1. In this video, we're going to be looking at how to find angles if we're given the trig ratios. So basically the opposite process to what we did in video 1. So let's look again at what should be in our trig toolkit in order to be successful with this math. So here it is. So of course we have to know what the trig ratios are. And that's what the word Sohcahtoa is designed to remind us. That sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tan is opposite over adjacent. So if I hear Sohcahtoa, if you hear me say Sohcahtoa, it's reminding myself what the ratios are. And of course below that, I've put that you also need to know the reciprocal ratios. Cosecant is the reciprocal of sine, secant is the reciprocal of cosine, and cotangent is the reciprocal of tan. What else do we need to know? Well, we need to know the cast rule. And the cast rule is simply a way of reminding ourselves that within the 4 quadrants in which a terminal arm can lie, different trig ratios will have different polarities, meaning positive or negative. So in the first quadrant, all of the ratios are positive, and then in the second quadrant, only sine and its reciprocal are positive. In the third quadrant, only tan is positive, and in the last quadrant, in quadrant 4, only cosine is positive. We also, of course, need to remember that there are some special angles, and when we work with special angles, we don't use our calculator, we give exact values. And the special angles are angles that have pi over 4, pi over 3, or pi over 6 as the related acute angle. And these triangles we memorize so that we know what all the sides are, so we can set up the side ratio when we need it. Of course, there are also super special angles, and the super special angles are, and if I go down to this diagram, 0, pi over 2, pi, 3 pi over 2, and 2 pi. And what I use is these diagrams and go 0, pi over 2, pi, 3 pi over 2, and 2 pi. And that's with sine, and down here is the cosine curve, and again 0, pi over 2, pi, 3 pi over 2, and 2 pi. So when I need to think about super special angles, these are the visuals I use. So for special angles, these are the visuals I use. So let's go ahead and do a question. Find theta given sine theta equals -1 over root 2 if theta is between 0 and 2 pi. So obviously it's important that we know where to look for an answer. It says to look only between 0 and 2 pi, and that's really significant because there are technically an infinite number of correct answers if this wasn't specified. Because every time you rotate around a circle, you're creating a terminal arm on top of a terminal arm that already exists. And so there's actually, if you continued rotating in a full circle, you would find an infinite number of answers. However, we're only going to look for answers between 0 and 2 pi, and that means within one full rotation. So where do we start? Well, we start with the sine ratio given. We're told that sine theta is -1 over root 2. So we know, we know that sine is negative in this question. So wherever theta is, it has a negative value of sine. So I'm going to use the cast rule. Oh, hold on. Let me get a pen. There we go. I'm going to use the cast rule and figure out where would my angle be, where would the terminal arm be in order to result in a negative sign. And again, I'm only allowed to look between 0 and a full rotation. So sine is negative. Here sine is positive. Here sine is positive. Here is one place where my terminal arm would lie because sine is negative, and here's another place. So within one full rotation between 0 and 2 pi, there's going to be 2 terminal arms that have a negative value for sine. So I should look for both answers. The next thing I need to do is figure out what related acute angle results in a sine ratio of 1 over root 2. So what related acute angle gives me the sine ratio of 1 over root 2? So this is why we have our special angles. So let me go grab our special angles so we can look at them. Boop, 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 boop. Here they are. So I put them in a package together because we need to know which one we're dealing with. So we know that sine, here comes Sohcahtoa, we know that sine is opposite over hypotenuse. And so the root 2 is the hypotenuse. So when I look at these two triangles, this triangle has a hypotenuse of 2. This one has a hypotenuse of root 2. So that's the winner. I need to use this triangle. Now within this triangle, there's only one angle that's relevant, but let's just stick around and make sure. Is the sine of this angle 1 over root 2? So opposite over hypotenuse, 1 over root 2. Yes, it is. So I know that my related acute angle, oh, I shouldn't write in yellow. I know that my related acute angle must be pi over 4 because it is the angle that results in an opposite over hypotenuse ratio of 1 over root 2. So when I take that related acute angle and I go to my diagram, I know that this will be pi over 4 and this will be pi over 4. So now I just have to figure out what is the actual angle that gets me to that terminal arm and what is the angle that gets me to the other terminal arm. So let me pull the page down a little bit and kind of redraw this a little nicer. So here's what we have. We have a terminal arm here where this is pi over 4. And we have a terminal arm here, I'll use a different color, where this is pi over 4. And so for the blue one, we want to know if this is what the related acute angle is, what's the principal angle for that rotation? So how do we figure that out? Well, this is why, and again, hopefully you watched the other video, I like really thinking about how this fraction stuff works. I know the related acute angle is pi over 4, which means that the more thinking I can do in terms of pi over 4, the better. And I've erased that because I didn't like it. I'm sorry. Here's what I'm looking at, and I know that this is pi over 4. Now, I've cut pi into 4 pieces. So normally, this would be 0, this would be pi over 2, and this would be pi. But because I've cut it into 4 pieces, I'm going to call it 4 pi over 4. It's still pi, but it's written sort of in the same language as what I want. So here's what happened. I started here, I rotated to 4 pi over 4 and a little bit more. 1 more pi over 4. So 4 pi over 4 plus 1 pi over 4, that would be 5 pi over 4. So this terminal arm is at 5 pi over 4. And then I do the same thing, but I'm going to draw a clean diagram just to make it clear. Now let's talk about the other terminal arm, which was in this quadrant. And again, we know that the related acute angle is pi over 4, but the question is, what's the actual principal angle of that rotation? So again, same idea, which is because I'm working with pi over 4, I want to think about all of the angles as pi over 4. So in other words, this is not pi, it's 4 pi over 4. This is not 2 pi, it's 8 pi over 4. So you can kind of approach this in a couple different ways. You can put this one back in and go 4 pi over 4, 5 pi over 4, 6 pi over 4, 7 pi over 4, that's the one I want. Or you could say, hey, if I wrote it the whole way, that would be 8 pi over 4, and then go backwards by 1, I'd be at 7 pi over 4. So there's the two answers that I have to give both of, because I need all of the answers that exist within one rotation. So if I were to take my calculator and I was to ask the calculator to find the sine of 5 pi over 4 or the sine of 7 pi over 4, my calculator would give me negative 1 over root 2, which, by the way, in case you're checking, is like 0.7071, I think. I don't know, I don't like decimals. So that's what we just did. We just discovered that the two angles that are the correct answer for theta are 5 pi over 4 and 7 pi over 4. That's what makes this a true statement. Let's try another similar one. Pardon me. So again, we're going to find theta, and we know that the tangent ratio is root 3. Now, if you don't like saying that, because we know tan is supposed to be Sohcahtoa, opposite over adjacent. So if it bothers you to just see this, then give both values by just putting it over 1. So opposite over adjacent is root 3 over 1. And again, I'm looking within one rotation. So first, let's think about quadrants. So I need tan to be positive. So where is tan positive according to the cast rule? So I need a terminal arm here because all of the angles are positive here. And I need a terminal arm here because that's also where tan is positive. So this related acute angle is important and this related acute angle. So now let's figure out what that related acute angle is. So what we know is that opposite over adjacent is √3/1. So now we need to find our special triangles. Here they are. So which one do I use? Well, this is the only triangle that has √3 in it. This one only has 1 and √2 for side lengths. So it's not this triangle that I care about, it's this one. Now I need whichever one of these angles, pi/3 or pi/6, I need one of them, the one that has the opposite is √3 and the adjacent is 1. So remember, an adjacent angle is the one next to it. Well, pi/3 is next to 1 and the hypotenuse. Pi/6 is next to √3, so it's not that one. So let's just double check that. Pi/3, if I wanted to find the opposite over the adjacent, I would do √3/1, so that's my related acute angle. So pi/3 is my related acute angle, so that's one terminal arm and that's another. So again, let me give myself some more room to draw that a little more nicely now that we know. So again, here's one terminal arm and here's the other terminal arm. So pi/3 is the related acute angle, but of course we want the actual principal angle. So this one's nice. It's always nice when things are in the first quadrant, because if I start here and rotate here, then the related acute angle is the same as the principal angle. So one of my answers is just pi/3. Now I have to worry about this other one. So here's the terminal arm. And if we start at the starting point and we rotate here, what should we actually call that angle? So I rotate it past pi, which in this case I would call 3pi/3. And then I went one more pi/3. So I went to 3pi/3, added another pi/3, and that would put me at 4pi/3. See how I'm not worried about common denominators and what's going on with pi? I'm just thinking about pieces. It's one piece, two pieces, three pieces to get here, one more piece, and each piece is called pi/3. So 3 plus 1 is 4, so 3pi/3 plus 1pi/3 is 4pi/3. So there's the two answers that lie within run notation. All right, let's look at another one. So we're finding theta, and this time we know that cosine theta is √3/2, but look at what I did. Aha, I changed where I want you to look for your answer. This time I want you to find all the answers that are between -2pi and +2pi. So let's think about that for just a second. Where do we start looking for answers? Well, we have to figure out where -2pi is, and then we'll start looking. So if I rotate backwards by 2pi, I'm back at the beginning. So here's me rotating backwards. So this represents -2pi. So where do I look for answers? I'm going to look for answers all the way up until 0. So all of these this red circular path represents places where answers might exist. Right now I'm only at 0. I have to go until I get to 2pi. So I'm going to keep going, and I know 2pi is here. So I'm going to keep going. Boom. So there are actually within each quadrant 2 possible answers that I'm going to have to give. So let's worry about that in a second. Let's start by figuring out what quadrant we need to look at, and we'll do that stuff, and then we'll worry about what else to do with this. So we know that cosine is positive. Cosine is positive in which quadrants? So let's use the cast rule. Cosine is positive here and here. So C meaning cosine and A meaning all of them. So those are the 2 quadrants we care about. So I should be able to find 1, 2, 3, 4 answers. Ooh, okay. Now let's think about what the related acute angle is, and then we'll worry about what the actual answers are. So the related acute angle has to do with cosine of √3. Sorry. The related acute angle can be found if we know what angle has a cosine ratio, meaning adjacent over hypotenuse, of √3/2. So we need to look at the special triangles and find what angle gives us that relationship. So again, what I want is a hypotenuse to be 2 and the adjacent to be √3. So I know it's not the first triangle because that doesn't have any side lengths that are √3. So I'm down here. I need the adjacent to be √3 and the opposite to be 2. So that's the angle I want because that angle has an adjacent of √3 and I don't care about that. So now I know what the related acute angle is. I know that it's pi over 6. So let me take this information and kind of start with a nice fresh thinking diagram. So we already know this quadrant and this quadrant are the only ones I care about. This is pi over 6 and this is pi over 6. So let's start. We know we have to go from 2 pi to 0 to 2 pi. So negative 2 pi to 0 to 2 pi. So let's kind of, what's the best way to do this? Let's actually use the counting concept. Because pi over 6 is the related acute angle, I'm going to divide pi into 6 pieces. So this is pi over 6, this is pi over 6, this is pi over 6, pi over 6, pi over 6, pi over 6. So of course this is 6 pi over 6. And then pi over 6, pi over 6. All of these will represent pi over 6. Even though, you know, it's a messy diagram and it doesn't quite look like it, that's what's happened. So let's go back to where we said we need to start looking, and that's at negative 2 pi. So again, we're going to start here, go backwards by negative 2 pi, and then start rotating. So right now I'm at negative 2 pi. And then every time I tick forwards towards my goal, which is over here, I remember that I'm taking pi over 6 off of what I'm doing. So if this is negative 2 pi, let's call that negative 12 pi over 6. Good idea. Because then this is just negative 11 pi over 6. And that's an answer. So again, I started at negative 2 pi over 6 and I went a little bit forwards. So I got a little bit less negative at a negative 11 pi over 6. Negative 10 pi over 6, negative 9 pi over 6, negative 8 pi over 6, negative 7 pi over 6, negative 6 pi over 6, negative 5 pi over 6, negative 4 pi over 6, negative 3 pi over 6, negative 2 pi over 6. Hey, negative 1 pi over 6, I want that. That's one of my terminal arms. So let's keep rotating, because remember, we rotate till we get here. I'm at 0, pi over 6. That's one of my terminal arms. So pi over 6, 2 pi over 6, 3 pi, 4, 5, 6, 7, 8, 9, 10, 11 pi over 6. So I have 4 answers, and there they are. Now that was a bit messy, so I'm just going to clean it up a little bit, just in case. So this was negative 11 pi over 6, because I was started here at negative 12 pi over 6, and I rotated back 1. And then we kept going negative 11, 10, 9, 8, 7, 6, 5, 4, 3, 2. This was negative pi over 6, and then we knew that because it's just 1 backwards. And then 0. And then pi over 6, that was an answer. And then, so that's 1 pi over 6, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 pi over 6. And those are the 4 answers that we have to give. And when you give your answers, make sure you don't separate them the way that they're written now. Write them as one answer, meaning these are the values, and put them in numerical order, meaning from smallest to largest. So those are the 4 answers for theta. I know backwards rotation can be a little weird, but remember, all you're doing is counting up when you start at a negative rotation. And I think there's another example coming up. Yep, good. So let's look at this one. Find theta given that cosine theta equals negative 1. Now negative 1 for cosine theta, remember this? There's the cosine curve drawn really terribly, but whatever. And if we go 0, pi over 2, pi, 3 pi over 2, 2 pi, that's where cosine is negative 1. When theta equals negative 3 pi over 2. Negative? No. Sorry. I saw this and my brain said a word. So again, in the cosine curve, the only place where theta gives a value of -1 for cosine is at 3 pi over 2. So that's my answer, except for I have to look within this range. So I'm not worried about quadrants right now because it's a super special angle. And I'm not worried about related acute angle because it's a super special angle. The only thing I have to worry about right now is dealing with this rotation stuff. So what are we going to do? So I need to look between -5 pi over 2 and, here's my other limit, hold on, and +3 pi. So what does that look like? Where am I starting? So -5 pi over 2, let's find where that is. So again, we're going to start here and we're going to rotate backwards until we get to -5 pi over 2. And we're going to do it by counting. And remember, each one of these axes lines or major dividers is 1 pi over 2. So if I start here, this is 1 pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2. Here is -5 pi over 2. So that's where I'm going to start my rotation. And then I'm going to have to rotate forwards from here until I get to 3 pi. So let's see what that would look like. So if I start here and rotate forwards, this is -4 pi over 2, or 0, but I'm not there yet. -4 pi over 2, -3 pi over 2, -2 pi over 2, -1 pi over 2, 0. Okay, I'm at 0. Now I have to go pi over 2, 2 pi over 2, which is pi, 3 pi over 2, 4 pi over 2, which is 2 pi, and then 5 pi over 2, 6 pi over 2, which is 3 pi, and that's where I stop. So if you look, I have to actually give 3 answers to this question because I know that 3 pi over 2 is here, and that's the major answer to this question if you want. But within this rotation constraint, there's actually 3 times that I actually touch that axis, which means I have to give all 3 answers. So I'm going to draw it again, just because I like things to be nice. So again, we're starting here, and we're going to see the rotations. And this is my terminal arm. That's the only angle I actually care about. And you can see I start off right on top of it at -5 pi over 2. So that's one of my answers. So if we start here, let's rotate. Ready? So -4 pi over 2, -3 pi over 2, -2 pi over 2, -pi over 2, that's an answer, 0, pi over 2, 2 pi over 2, also known as pi, 3 pi over 2, that's an answer, 4 pi over 2, 5 pi over 2, 6 pi over 2, 6 pi over 2 is where I wanted to stop, because that's 3 pi, and we knew we were only looking for 3, and there they are. So those are my answers for theta. Takes a bit of practice, and it's certainly not the only method. You know, if you had a more comfortable method, if you've memorized formulas, use them. I just am a visual person, and I like just counting sometimes. So we solved for theta, that value of theta. Those 3 values of theta are the 3 values within this range that make this a true statement. So here's just one more question. Let's see how to do it. It's slightly different, but it still involves the same concept. It says the terminal arm of a rotation by theta, I guess I forgot to put that, passes through the point -6, -9. We want to find theta, and okay, we're back to normal rotation. That's nice. So here's my Cartesian plane, and let's figure out where the terminal arm is. So to find it, we need to go -6, -9. So it's right about here is the point, which means here is the terminal arm. So this question wants me to find what theta would be to get to this terminal arm. So how are we going to do that? Well, we need to use trigonometry, obviously, which means we need a triangle. So let's create the triangle by drawing the line, that the third side of the triangle, which goes to the x-axis, and then using this information to think about the side lengths of that triangle. And in fact, I'm going to redraw it over here Ooh, that didn't quite work. Just to keep my diagram a little nice. So here's the triangle that I've drawn. I'm just moving it out here. So remember, this point was at -6, -9. To get to it, we started here. We went 6 units in this direction, and we went 9 units down. And what we want to do is we want to find theta, but in the triangle, we're going to start by finding the related acute angle, and then we'll talk about how to find it. Now, we could use sine, except for we don't have the hypotenuse. Pythagorean theorem? Sure, if you want. I don't want. Because I already have the opposite and the adjacent side, which means I can just use tangent and not worry about too much. And the extra nice thing about that is that tan is positive because of the quadrant that I'm in. So I don't have to worry about what's negative, what's positive. Is it -6 or 6? I just use logic. I'm going to use tan. I'm in a place where tan is positive. So I know that tan of the related acute angle is opposite over adjacent. So here's that related acute angle. So opposite over adjacent is 9/6. Now, if I were to reduce that, even though I don't technically have to, I'm just doing it to show you something. Here I have a denominator 2. And whenever I see a denominator 2, I'm going to want to look at this to see if this is a special angle. So if I have a hypotenuse of 2, like I do in this triangle, is one of these angles, pi over 3 or pi over 6, can I possibly create opposite over adjacent? Sorry. Oh, in fact, that's not even logical. I need opposite over adjacent to be 3/2. That's not possible in either of these triangles. So what does that mean? Well, it means this isn't a special angle. This is just a calculator question. What? I know. That's why I'm messing up, because I'm not used to it either. But it's still an important calculator question, because just because we're using our calculator for one tiny little step, but that doesn't mean the calculator knows what to do. So we know, again, that the tan of the related acute angle is 3/2. So we're going to use inverse tan to find the answer. Now make sure you are in radian mode, or else your answer will be in degrees, and that would make everybody sad. So inverse tan, radians, good. Inverse tan of bracket 3 divided by 2. Bracket. So my calculator says 0.98. So remember, that is a radian measurement, and it's in degrees. 0.98 of a radian, where is that? Well, this is pi radians. So this is half of that. So 0.98 is about here-ish. Again, not to scale. But I know from the visual I made, let me move this, that I'm supposed to be in quadrant 3. My calculator doesn't know that. Aha, that's why we can't just say, hey, calculator, no thinking. We have to remember that this is just the related acute angle. We are in this quadrant. All we did was calculate this. It's 0.98. What we actually want to answer is the principal angle, which starts here. So look at what I've done visually. I know that to get from here to the halfway around the circle is pi, 3.14. And this angle is a little bit more. How much more? 0.98. So my answer can be found by just adding 0.98 to 3.14. So theta is 4.12 radians. Okay? So yes, sometimes you do use your calculator, but it doesn't mean you shut off your brain. All right, so I hope that that's helpful. Maybe more videos to come. I don't know. Not right now, though. Take care. Do your homework.